Isaac, and you are welcome to my chemistry class. Today, I shall be taking you through alkanols, or you can say alcohols. Before now, I have been able to establish that organic chemistry is the study of the compounds of carbon, except the carbides, oxides, sulfides, and carbonates of carbon. The compounds of carbon alone is more than the compounds of every other element in the periodic table combined. This is as a result of the unique ability of carbon to catenate and due to hybridization of carbon. I was able to explain homologous series where I said that homologous series is a family of organic compounds which follow a structural pattern, a regular structural pattern, and each successive member differ from the other by a CH2 group. I listed out all the organic compounds and their homologous series. From there, I explained functional group. I said that functional group is an atom, ion, or radical that is common to a homologous series. Now, any homologous series that has the functional group OH is referred to as alkanon. Therefore, alkanon is a compound or organic compound with the functional group OH. And this OH can also be referred to as hydroxy group. When a hydroxy group OH is attached to a general formula, we form alkanols. For example, you see this general formula, OH is attached. You see this arrow, OH is attached. Therefore, alkanols is formed. Now, what is this general formula? This general formula is referred to as the alkyl group. Alkyl groups are groups or compounds formed when alkanes lose one hydrogen. The general formula for alkanes is simply CnH2n plus 2. More of that in my hydrocarbon videos. Now, CnH2n plus 2 is the same thing as if n is 2, which means we have 2 carbons, we simply have C2H, 2 times 2, 4, plus 2, 6, H6. This is an alkane. An alkane having 2 carbons is referred to as ethane. Now, drawing this, we have 2 carbons, 6 hydrogens, 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen, 5 hydrogens, and 6 hydrogen. Now, carbon is tetravalent. This implies that it can carry a maximum of 4 bonds. So, 1 here, 1 here, 1 here, 1 here. The bond is complete. Alkanes can undergo substitution reaction. They cannot undergo addition reaction. This is because they are saturated. This carbon already has 4 bonds. This one already has 4 bonds. And each of the bonds are single. So, you cannot say, okay, let me add anything or attach. It cannot undergo addition reaction. Addition reaction is the property or characteristics of unsaturated compounds like alkenes, presence of double bonds, alkynes, presence of triple bonds, where you can break the bonds to add atoms. Since alkanes can only undergo substitution reaction, so one of them can be substituted. So from here, you can keep break here to substitute. What if in this case, you choose to substitute OH? You say, okay, let OH be here. You formed alkanon. And this alkanon formed is referred to as ethanol because it is formed from ethane. That is the logic. So, leaving here blank, this is simply C2H5. And you can have any number of carbon, 3, 4, 5, 6, 7, 8. In that case, let the number of carbons be n. So here, 2 times the number of carbons. So when a hydroxy group is attached to a general formula, will form alkanols. Now, if you have arrow and arrow prime, they mean the same thing. So this means an alkyl group, this means another alkyl group. Classification of alkanols or alcohols. Alkanols can be classified based on the number of hydroxy group and position of the hydroxy group. These are two ways we classify alkanols, based on the number of hydroxy groups and based on the position of the functional group. Based on the number of hydroxy groups, alkanols can be monohydric, dihydric, trihydric, and polyhydric. What is monohydric? Monohydric alkanols are simply alkanols that have only one hydroxy group. They have only one OH. Dihydric alkanols are alkanols that have only two OH group in the atom, while trihydric alkanols, they have three OH group in the atom. On the other hand, polyhydric alkanol is simply an alkanol that has more than three OH group. According to the number of hydroxy group, we have monohydric alkanols, dihydric alkanols, trihydric alkanols, and polyhydric alkanols. Monohydric alkanols, they have one OH group. Dihydric alkanols, they have two OH group. Trihydric alkanols, they have three OH group, and polyhydric alkanols, they have more than three OH groups. Diagram shortly. And based on the position of the hydroxy group, we can have primary alkanols, secondary alkanols, and tertiary alkanols. According to the number of hydroxy groups present in an alcohol, it can be monohydric, dihydric, trihydric, or polyhydric. Now look at this alkanol. You see the OH group, just one. Since it has just one OH group, it is referred to as monohydric alkanol. And the name of this compound is ethanol. So example of a monohydric alkanol is simply ethanol. Now look at this compound. You see one OH group here and you see another OH group here. This alcohol or this ethanol has two OH group. Since it has two OH group, it is simply dihydric alkanol. Example of a dihydric alkanol is simply ethan 1,2-diol, also referred to as glycol. Take a look at this alkanol. It has, look at it, one OH group, another OH group, and another OH group. It has three OH group. So it is simply a trihydric alkanol. A trihydric alkanol is simply any alkanol that has three OH group. Now, some persons will choose to classify alkanols into monohydric, dihydric, and polyhydric, meaning anyone that has three or more can be polyhydric. But in this case, we have monohydric, dihydric, trihydric, and polyhydric. Look at polyhydric alkanol. Example of trihydric alkanol is simply propan 1,2,3-triol, which is referred to as glycerol. It has three hydroxy group or three OH functional group. Polyhydric alcohol, example is glucose. Any alcohol or any alkanol that has more than three OH group is referred to as polyhydric alkanol or polyhydric alcohol. As you can see, we have many OH group present in glucose. Now, I hope you understand classification of alkanols according to the number of hydroxy group. Now, let's see classification of alkanols or alcohols according to the position of the hydroxy group. Here, we are only concerned about how many hydroxy group we have. But here, we are concerned about the position of the hydroxy group. So based on the position of the hydroxy group, we have primary 1, then 0 on top, like 1 degrees, secondary 2 degrees, tertiary 3 degrees. This is it. Primary alkanols is simply any alkanol or alkanols that have the OH group, only one carbon is linked to the OH group. Only one carbon is attached to the carbon carrying the OH group. Primary alkanol is simply any alkanol that has just one carbon directly linked to the carbon carrying the OH group. In other words, primary alkanol is alkanol that has the hydroxy group attached to the primary carbon. Look at it. This is the hydroxy group, right? This is the carbon attached to the hydroxy group, right? Now, how many other carbons or how many other carbon is directly linked to the carbon carrying the hydroxy group? So this carbon is linked to this is linked to this. So only this carbon is directly linked to the carbon carrying the OH group. So this is a primary alkanol. You understand better now. Look at this. This is the hydroxy group, right? Now, which carbon is carrying the hydroxy group? It is this one. True or true? True. Now, how many other carbons are directly linked to the carbon atom or to the carbon carrying the hydroxy group? This is the one carrying the hydroxy group. You see, this carbon is attached to it. This carbon is attached to it. Therefore, two carbons are attached to the carbon carrying the hydroxy group. So this is a secondary alkanol. This carbon is referred to as primary carbon. Only one other carbon is attached to it. Now, this carbon, two other carbons are directly linked to it. So this is a secondary carbon. Therefore, an example of primary alkanol is propanol or 1-propanol. Example of secondary alkanol is simply 2-propanol because it has two carbon atoms attached to the carbon atom carrying the hydroxy group. Look at tertiary alkanol. This is the hydroxy group. This is the carbon linked to the hydroxy group. Now, how many other carbons are linked to the carbon that is carrying the hydroxy group? This one is linked to it directly, this one is linked to it directly, and this one is linked to it directly. So this is a tertiary carbon. So when three other carbon atoms are directly linked to the carbon carrying the hydroxy group, it is referred to as tertiary alkanol. An example of tertiary alkanol is 2-methyl-propan-2-ol. So, ladies and gentlemen, I've been able to explain classification of alkanols according to the number of hydroxy groups and according to the position of hydroxy groups. Now, we know that alkanols are compounds in which the hydroxy groups are attached to a general formula. We also know that alkanols can be classified based on the number of the hydroxy groups and based on the position of the hydroxy groups. Now, how do we prepare alcohols or alkanols? Alcohols can be prepared in two ways, either in the lab or in the industry. Now, laboratory preparation is simply for preparing compounds or substances in small quantity. You simply carry out some reactions, some experiments, you produce what you want in low scale. But industrial preparations are for preparing compounds or substances or products in large scale. To prepare alkanols or alcohols in the lab, you simply react ethene with water gas, which is referred to as steam. When water is in gaseous state, you refer to it as steam. So when steam reacts with ethene, you form alcohol or alkanol. And the alkanol form is simply ethanol. This does not happen without the presence of a catalyst. So the catalyst used is simply H2SO4, tetraoxosulfate 6 acids. Therefore, when ethene is react with water, gas, ethene reacts with steam in the presence of H2SO4, we form an alkanol or we form ethanol. When ethene reacts with water, we form alcohol. That is a way to prepare alcohol in the lab. How about in industries? In industries, alcohols are produced in large scale via a process referred to as fermentation. We know fermentation of carbohydrates. This is simply a natural or organic process. Now look at it. When starch is being acted upon by diastase, which is an enzyme. It changes to maltose. Now look at it. Here I said H2SO4 is a catalyst. Now I am saying diastase, which is here, is an enzyme. There is difference between catalyst and enzyme. Catalysts are substances that help to increase or reduce the rate of chemical reaction. Now, if reaction occurs slowly and you want it to be faster, you use enzyme to influence the reaction. You use catalyst to influence the reaction. In that case, that catalyst is positive catalyst. Now, if a reaction is too fast, you want to slow it down, you need negative catalyst to slow down the reaction. Catalyst acts by reducing the activation energy. In summary, catalysts are substances that help to improve or increase the rate of reaction. These catalysts mostly they are inorganic. They are made, they are not natural from natural sources. For example, H2SO4 is inorganic, it is a catalyst. Enzymes, on the other hand, are organic catalysts. Organic catalysts that help improve the rate of reaction. So organic catalyst means they are from natural source, they are from organic sources. So that is the difference between enzymes and catalysts. Enzymes are organic catalysts. So when the enzyme diastase acts on starch, it changes starch to maltose. Now diastase is gotten from malt. So you may be asked, what is the source of the enzyme diastase? It is simply from malt. So from starch to maltose, you need the enzymes diastase from malt. Now maltose changes to glucose and the enzymes that works there is maltase. Maltase. This maltase is from yeast. So diastase acts on starch, maltase acts on maltose to form glucose. Remember, I drew the structure of glucose earlier, and you see that glucose has a lot of OH group attached to it, and I said it is polyhydric. Now, an enzyme called zymase from yeast acts on glucose to convert it to ethanol and carbon 4 oxide. Therefore, industrial preparation of carbon 4 oxide of alcohol is via fermentation of carbohydrate. So starch changes to maltose via enzyme called diastase, and diastase is from malt. From maltose to glucose, enzyme maltase from yeast acts, and from glucose to ethanol and carbon 4 oxide, zymase acts. So you can say DMZ for the enzymes: diastase, maltase, and zymase. Then if you want to crown the sources, it is simply MYY. From malt, from yeast, or from yeast. Zymase is from yeast. Now look at another way to prepare alcohol in the lab. From sucrose, you convert sucrose directly to glucose using an enzyme called invertase. Invertase is from yeast. Then from glucose to ethanol and water, zymase from yeast. Meaning, in this case, you are skipping here. You are going directly to glucose. Let's take a look at the properties of alkanols or properties of alcohols. The first one here is boiling point. The boiling point of alkanols or of alcohols is 78 degrees Celsius. This is high. Yes. Generally, organic compounds have low boiling point, but alkanols, on the other hand, disobey this law. Why? This is because of the presence of hydrogen bond. In the OH group. So you may be asked, organic compounds generally have low boiling point, but what is the reason for high boiling point in alkanols or in alcohols? It is as a result of the hydrogen bonding. Now, alkanols or alcohols are neutral to litmus. Litmus is used to test whether a substance is acidic, basic, or neutral. An acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion. That is according to Arrhenius. Then Bronsted and Lowry stated that acids are proton donor while bases are proton acceptor. Then according to Arrhenius as well, bases are substance which, when dissolved in water, produces hydroxyl ion. So alkanols are neither acidic nor basic to litmus. The third property of alkanols is oxidation. In my video on redox reaction, I explained that oxidation can be defined under different subheadings. For example, when it comes to oxygen, oxidation is the addition of oxygen. Reduction is the removal of oxygen. When it comes to hydrogen, oxidation is the addition, removal of hydrogen. Reduction is the addition of hydrogen. When it comes to electrons, oxidation is electron loss. Reduction is electron gain. When it comes to oxidation number, oxidation leads to increase in oxidation number. Reduction leads to decrease in oxidation number. When it has to do with electronegative and electropositive species or elements, oxidation is the addition of electronegative elements and removal of electropositive elements, while reduction is the addition of electropositive elements and removal of electronegative elements. Now, in this case, oxidation, what happens in oxidation of alkanols? Oxidation of alkanols can be explained under primary, secondary, and tertiary alkanols. When you oxidize primary alkanols, partially you get alkanol. When you oxidize primary alkanols completely, you get alkanoic acids. So, primary alkanols can be oxidized. Don't look as if you don't know what I'm talking about. I explained primary alkanols. They have one other carbon atom attached to the carbon carrying the OH group. So, look at this alkanol. This is a primary alkanol. When you oxidize primary alkanol, you form alkanal. Now, to oxidize alkanols, you simply use acidified dichromate solution or acidified permanganate. So, heptaoxodichromate 6 or permanganate 7, tetraoxomanganate 7. Now, look at this. In the oxidation, when you use acidified dichromate, the solution changes from orange to green. When you use acidified permanganate, solution changes from purple to colorless. So, when you oxidize primary alkanols, you form alkanals. This is partial. Now, complete oxidation of primary alkanols will give you alkanoic acid. Before I explain the structures once again, primary alkanols can be oxidized partially or totally. So when you oxidize primary alkanols partially, you form alkanals, Al. When you oxidize primary alkanols completely, you form acids, alkanoic acids. So look at this. This is butanol, 1, 2, 3, 4, 4 carbon OH, which is primary alkanol because only one carbon is directly attached to the carbon carrying the OH group. Now, oxidation in this case, this oxygen removal of hydrogen. So this hydrogen was removed, this hydrogen was removed. What happens? Hydrogen removed, another hydrogen removed, double bond is being formed to O. This is an alkanal. Now, there is a difference between alkanals and alkanones. For alkanals, you see the carbon to double bond to oxygen, they are at the terminal. You see what I'm talking about. So this is an alkanal. When you further oxidize, you form alkanoic acid, which is addition of oxygen to form butanoic acid. Alkanoic acid has the functional group COOH. Meanwhile, alkanols have OH. So when you add another O here, you form COOH. That is alkanoic acid. So when you completely oxidize primary alkanols, you form alkanoic acids. When you partially oxidize, you form alkanal. So oxidation of butanol gives butanoic acid. But if you are told partial oxidation, then the result is butanol. How about secondary alkanols? Looking at this alkanol, you see this is the carbon carrying the OH or the functional group. You have two other carbon directly linked to it. This is a secondary alkanol. When you oxidize secondary alkanols, you form alkanols. So primary alkanols can be oxidized to form alkanoic acid and partially oxidized to form alkanals. But when you oxidize secondary alkanols, you form alkanone, O-N-E. So this is a secondary alkanol. You oxidize it still using catalyst. You can either use this catalyst or you use this. You get the same result. Look at the product formed. Look at what happened here. Hydrogen is being removed. The removal of hydrogen is oxidation. So therefore, we have C double bond to O. The difference between this and this is that C double bond to O is in the middle, it's not terminal. While here, C double bond to O is at the edge. That is the difference between alkanals and alkanones. So in alkanals, the double bond to O, C double bond O, is at the edge. In alkanone, O-N-E, it is at the middle. So in summary, the oxidation of primary alkanols will give you alkanoic acid, complete oxidation. Partial oxidation will give you alkanals. For secondary alkanones, oxidation of secondary alkanones will give you alkanone, O-N-E. And I explained the difference between alkanals and alkanones. How about tertiary alkanols? Tertiary alkanols cannot be oxidized. The solution doesn't change color. So tertiary alkanols cannot be oxidized. Tertiary alcohols cannot be oxidized. Another property of alkanols is simply esterification. When alkanols react with alkanoic acid, we form esters and water. Esters are alkyl alkanoids. They have sweet smell. Then finally, dehydration. Drying is the removal of water, but dehydration is the removal of elements of water, hydrogen or OH, H plus or OH, and it alters the structure of compounds. So let's see equation of reaction for esterification, dehydration, and uses of alcohol. When alcohols react with acid, the process is referred to as esterification. This is because the products are usually esters and water. So look at this alcohol or this alkanol. We are using ethanol as a representative. It reacts with propanoic acid. So this is an alkanol, this is an alkanoic acid. It forms ester and water. The ester formed here is ethyl propanoate and H2O. The reaction is reversible, which means when esters or when an ester reacts with water, the product is simply ethanol and ethanoic acid. Now this is the compressed structure. So if you expand this, ethanol CH3 CH2OH is simply CH3 CH2OH reacting with propanoic acid CH3 CH2COOH CH3 CH2COOH. Now this OH, something like this, is the same thing as something like this, COH, because the double bond is from carbon to oxygen and from oxygen to hydrogen to give us ester. Ethyl propanoate, this is ethyl. Propanoate will have 3 carbon. So this is CH3, CH2, COO, CH2, CH3, so plus H2O. So that is it. Esterification. Alkanols react with alkanoic acids to form esters and water. And for dehydration, in the presence of concentrated H2O, excess H2O at high temperature, you can dehydrate alkanols to give you a tint. So Ethanol is dehydrated to ethene in the presence of concentrated H2SO4 at high temperature. Here, conc H2SO4 is serving as a dehydrating agent. Earlier, it serves as oxidizing agent. Oxidizing agent dey causes other species or other compound to be oxidized, and they are the one reduced in the process. So, ethanol can be dehydrated to ethene under one condition, two conditions. The H2SO4 must be concentrated. Two, the temperature must be very high. Otherwise, when you have at low temperature and excess alkanol or excess ethanol instead of excess acid, you form ethoxyl ethane. So what are the uses of alkanols or ethanol as a representative? Alkanols are used, or ethanols, they are used in racing cars. They are used as fuel in racing cars and rockets. Alcohols are present in alcoholic beverages. You say, give me that wine, I want to take some alcohol. Does it contain alcohol? So millions, thousands of wines or drinks, they contain alcohols. So you see, it has wide application. The alcohol, they are sometimes used as antifreeze. Then alcohols are good solvents, especially for drugs, tincture, cosmetic and perfumes. When iodine dissolve in alcohol, you form tincture of iodine. You see, it is acting as a solvent. We have solvent and solute. If this is B and this is A, if you can pour A inside of B to dissolve, A is solute, B is solvent. So water is universal solvent because it can dissolve a whole lot of solutes. Then alcohol can be used as fuel. Ladies and gentlemen, I hope I've been able to do much under alcohols and organic chemistry. If you found this video helpful, feel free to comment. Don't fail to let your friends know about Flash Learner's YouTube channel. Subscribe to this channel for more amazing videos and see my many other videos, chemistry and other subjects. Thank you.